Lesson 4 is about arithmetic review, and in the Saxon book there are several sections to this lesson, so it's going to take us a little while to get through it. Just be patient. Remember, have a good attitude about doing your work, not just math, but any schoolwork that you're doing. It'll make it a whole lot more enjoyable and maybe even fun for you if you try hard, try to figure it out, and make the best of this chance to learn. Part A is on numerals and numbers. Now, we use symbols to represent an idea of a quantity. For example, I could draw a couple of circles on the board, and that would give us the idea of 2. I could also represent the idea of 2 by a symbol, such as 2, or even a fraction, because 4 divided by 2 also equals 2. So in arithmetic, we use numerals, such as 2. 2 is a numeral. We use those to represent the value or a number. Now, we use a special system of numerals to designate what a number is, and that's called the decimal system. And those consist of what are called digits, and those are 0, 1, 2, 3, 4, 5, 6, 7, up through 9. Those are the digits that we use to create numerals, and those designate a number or a value. Now, a special group or set of numbers that we use a lot are the natural or the counting numbers, and those are from when you're a little kid. You start counting things. 1 had 1, 2, 3, 4, 5. You don't start with 0, but you start with 1. And so the natural or counting numbers, those start with 1, 2, 3, and so on. Those do not include decimal numbers like 1.4, 1.5, things like that. They just include those whole numbers like that. They start with 1. Another set of numbers are called real numbers, and a good way to understand real numbers is by using something called a number line. Now, I'm sure you're familiar with number lines. It's just a line, and it's kind of like a ruler, except it doesn't have ends on it, and you can just put tick marks on this line to represent specific locations. And for example, we'll start here and we'll call that 0. Now, positive real numbers, those could be numbers like 1, 2, 3, 4, and 5. So positive real numbers, those include the natural or counting numbers, but they could also represent numbers in between those, like a position in between 1 and 2. Let's say that represented 1.5. And so we could just represent that. We could write 1.5 up there. Or we could use the decimal form and say 1.5. So real numbers, those include the counting numbers as well as the fractions and decimals in between those. And then also for every positive real number, it has an opposite or negative counterpart. For example, the opposite of 1 would be -1. Opposite of positive 2 would be -2. Positive 3 would be -3. Now, notice we put that negative symbol in front of those numbers. Specifically, the ones to the left of the 0 on a number line. Those are all negative numbers. And so we could do the negative counterpart of 1.5. We could put that, I'll put a white dot right there, and we'd say -1.5. So we always put a negative sign in front of those negative numbers. Positive numbers, we don't put a positive sign in front of those. We just understand that those are positive. So number lines, those are helpful in comparing different numbers and different values. Number lines are kind of like a ruler, except that they go on forever in both directions. That's represented by the arrows on the end. And then they can also have negative numbers on them, which you usually don't put on a ruler. Let's continue the arithmetic review by working with some multiplication and division of fractions. If you recall, in Lesson 1, we reviewed addition and subtraction of fractions. Let's just go ahead and do some practice problems here. First, let's go ahead and do a multiplication problem. 3/5 times 1/4. Now, let's just think about what that means there. It means 3/5 of 1/4. So just to use a picture to understand what multiplication of fractions means, let's just take a circle, split it into fourths, and let's just think of one of those sections and think of 3/5 of one of those 1/4 sections. So we can split this into 5 sections like that and just shade in 3 of them. And so that would represent 3/5 of 1/4. So 3/5 of that 1/4 section, and the way we figure out numerically what that equals is we just multiply numerators together. 3 times 1 is 3, and then multiply the denominators. 5 times 4 is 20. So 3/5 of 1/4 is equal to 3/20. So 3/20, that's a fraction of the entire circle. Basically what that's saying is that that entire circle, we could break that into 20 sections, and 3 of those would be shaded. Let's do a little more complicated fraction multiplication now. 2 1/3 times 5 1/6. Now, in addition, we could add the whole number parts and the fraction parts and then combine those together later. You can't do that with multiplication of fractions. You have to convert both mixed numbers into improper fractions first. Let's just review that real quick. I'll do it the long way, and then I'll show you the shortcut on changing a mixed number into an improper fraction. The long way is to just look at 2 1/3. We'll do that one right now. Think of that as addition, 2 plus 1/3. And then we want to add those two things together, so we need to take that 2 and turn it into a fraction. Well, you know that anything over 1, we can write any whole number over 1 and turn that into a fraction. And then they both have to have common denominators, so we need to multiply that by 3 over 3. And so then we would get 6 over 3 plus 1 over 3. That equals 7/3. Okay, so that's our improper fraction form of 2 1/3 is 7/3. The shortcut method on that is just to multiply the whole number by the denominator, which is 6, and then add the numerator to that, and that would be 7, and then we write it over the denominator of 3. So let's do that for 5 1/6. We do 5 times 6 is 30. Add the numerator, which is 1, so that would be 31 over 6. Okay, so then let's put our 7/3 in here. 7/3 times 31 over 6. First, we look for things to simplify here, and I don't see any way we can reduce either of these fractions or anything to cancel in either fraction. So let's just go ahead and do the multiplication. 7 times 31 is 217, and then over 3 times 6 is 18. Now we need to write our answer as a mixed number, so that means we need to do division here, and our remainder is the fraction part. And so we'd say 18 into 217. 18 goes into 21 one time. We subtract and get 3 and bring down the 7. 18 goes into 37 two times, and 18 times 2 is 36. And so we get 1 as a remainder. And so our answer, therefore, is 12 1/18. So multiplying complex fractions like that, we have to do a few steps here. First, you convert them into improper fractions, then multiply numerators and denominators together. Simplify, reduce, if you can, before you do that multiplication. Then convert back to a mixed number. We usually don't write our answers as improper fractions. We write them as mixed numbers. Now let's do some division of fractions. We'll start out with an easy problem just to understand division. 3 divided by 1/2. Now the way to think about division is, for this problem, you'd say, how many halves can 3 be broken up into? So if you're ever confused about a division problem or just how that works, just think about that. Take the divisor, that's the second number there, and say how many halves could 3 be broken up into? How many of the divisors could that dividend, or the first number, be broken into? So let's just think about this. Let's have 3 circles. Okay, each one representing a whole, or 1. How many halves could we break those 3 up into? Well, the first one could be broken into 2 halves, the second into 2 halves, and the third into 2 sections that would equal a half. So our answer should be 6 here, 6 halves. So we know that the answer should be 6 here. Let's do a shortcut here on the division. What you do, you can write 3 as 3 over 1, and you change the divisor, you invert it, make it a 2 over 1, and multiply. And so you get 3 times 2 is 6 over 1 is equal to 6. So that's a shortcut in the method that you use to calculate a division problem. Now let's do a little more complex one. 2 1/3 divided by 3 5/6. So what we're asking there is how many 3 5/6 could we divide 2 1/3 up into? Well, just think about that. We can't divide 2 1/3 into a total 3 5/6, so our answer is probably going to be some fraction. And so let's first, just like in multiplication, change these to improper fractions. And so we'll say 2 times 3 is 6 plus 1 is 7/3. And then divided by 3 times 6 is 18 plus 5 is 23 over 6. 7/3. Now we do our invert and multiplication times 6 over 23. Now let's simplify if we can, and we see that we have a 6 over 3, which would simplify to a 2 over 1. And so we end up with 14 over 23. And just like we thought, we get a fraction less than 1 because we were trying to find how many 3 5/6 would go into 2 1/3. We can always check our work to make sure we did it right. We can multiply 14 23rds by 3 5/6, or 23/6. The 23's would cancel. 14 over 6 would simplify to 7 over 3. And so our answer is 7 over 3, which was that original 2 1/3. Just like in multiplication of fractions, you need improper fractions first, and then you change. One thing that you do different compared to multiplication is that divisor, you invert it and change it to a multiplication problem. Simplify as you need to first, then do your multiplication and get your answer. Section F of this lesson is on symbols of equality and inequality, and that's just a real basic thing. Like 4 plus 2, you put a symbol that's called an equal sign there, 6. An inequality symbol is just like an equal sign with a slash through it. And you would say that for that example there, because 4 plus 2 is not equal to 7. In section G, we're going to talk about the definitions, some of the definitions you need to know in the basic arithmetic operations, which are addition, subtraction, multiplication, and division. Now, in an addition problem, you have 2 addends, and those add up to equal a sum. The result of addition is called the sum, and that's the most important thing that you need to remember about addition and any of these operations is what is the result of that operation called? Because you might have a problem that says what is the sum of 2 and 5, and if you don't know what sum means, then you might think, oh well, that means I need to multiply 2 times 5. But no, it means to add, because sum, that's by definition, that's the result of an addition problem. Now subtraction, you have 2 numbers that you want to subtract. They have really strange names for them. The first one you call the minuend, and the second one the subtrahend. The most important one for you to remember is the result of subtraction. That's called the difference. So the result of subtraction, that's the difference. The result of addition, that's called the sum. Multiplication, the 2 numbers, they both are called the same thing, just like in addition, they're both called addends. Multiplication, they're both called factors. And those 2 factors you multiply those together to get a product. And that's what the number on the right side of the equal sign is called, is a product. And then division, you have a division symbol. And there's different ways to write division. Just like in multiplication, you could have 2 and then like a little X symbol, that means multiplication. Parentheses means multiplication as well. Division, you could have that division symbol. It could look like a fraction as well. That's representative of division. In the first example, the number on the left is called the dividend, and the number on the right of the division symbol, that's called the divisor. In a fraction, the top is called the dividend and the bottom is called the divisor. And the result of division, that's called the quotient. So the result of division is a quotient. The result of multiplication is called a product, subtraction the difference, and addition the sum. The other terms that are probably the most important to remember are factors. Those are the numbers that are multiplied together. And then know the difference between a dividend and a divisor. You hardly ever use addends or subtrahend and minuend in problems. Those terms are rarely used. Section H will do some practice problems on doing the basic operations of addition, subtraction, multiplication, and division using decimal numbers. Let's do an addition problem first. 2.7 plus 3.635. Now, the best way to do these is to line up the numbers vertically, and you line the decimal places up. So we'd put the decimal point right above the other one, and then do 6, 3, 5. Doesn't matter which number is on top. Now we can add up these empty spaces or fill up these empty spaces with zeros, just if you want to have a number there to help you remember, oh, I'm adding 0 plus 5, not just blank plus 5. I'm adding 0 plus 5. And that would be 5. 0 plus 3 is 3. 7 plus 6 is 13. So we carry a 1. And then 3, 4, 5, 6 is the total there to the left in the ones place. So 6.335 would be the result there. Or the sum, I guess, would be the more appropriate way to discuss that since it's an addition problem. Let's do a subtraction problem now. 3.635 minus 2.7. Well, I'll just scratch this minus 2.7 out and put it down here. Remember, we still line up the decimal places. In subtraction, that's important as well. Okay, and we can put some zeros in here. And so we'll do 5 minus 0 is 5. 3 minus 0 is 3. And then 6 minus 7, we can't do that. So we need to borrow from the ones place. So we make that a 2 and bring that over here. 16 minus 7 is 9. And then 2 minus 2 is 0. So 0.935 is the answer there. That's our difference between those two numbers. Now, in these problems, the purpose is to help you remember how to do multiplication. So don't be using your calculator to do these kinds of problems. There are times when a calculator is appropriate, like I said in the previous lesson on perimeter. It's okay to use them then, because that's not the purpose of the problem, is for you to know how to do multiplication. It's how to apply a formula. In these problems, though, that's the purpose of them, is to see if you know how to do multiplication and do that operation. It's important to remember how to do these operations because sometimes your calculator may break or you may want to check your work. And on many, many problems, it's faster just to do a multiplication operation on your paper than to do it on the calculator. So in G, we'll be finding the product here. Let's just go ahead and rewrite this. 3.635, and I'll put the 2.7 down here. Best way to do multiplication problems with decimals is to ignore the decimal points for now, then you add them back up when you're done with the multiplication. So let's go ahead and multiply the 7 by the first number, and 7 times 5, that's 35. carry a 3 there. 3 times 7 is 21, plus 3 is 24, carry a 2. 6 times 7 is 42, plus 2 is 44, carry a 4. And then 3 times 7 is 21, plus 4 is 25. Now we'll do the 2. 2 times 5 is 10, so that would be a 0 there, carry 1. 3 times 2 is 6, plus 1 is 7. 2 times 6 is 12, so we'll have a 2 down there, carry a 1. 3 times 2 is 6, plus 1 is 7 again. We add these up, and I'm running out of room here, so I'll do the answer over to the right. And so we'd have 5, 4, 1, carry 1, and 5 plus 2 is 7, 8, and then 9. We have 4 decimal places total here, so we start at the right and we move over 1, 2, 3, 4. So it would go between the 9 and the 8. 9.8145. So that's the product of 2.7 times 3.635. If you remember, the way you do place values, or decimal places, is you don't worry about place value until the end. You pretend like the numbers are whole numbers. Ignoring the place value is kind of like multiplying the problem by whatever factors of 10 you need to get rid of the decimal places, and then dividing those back in later. So you could think about it like in this problem, we multiplied everything by 10,000 and we got 98,145, and then we divided back by 10,000 to get the actual answer. We do it that way. We ignore the place value in this multiplication because it's simpler to work with whole numbers than with decimal numbers. Let's do a division problem and figure out the quotient for this problem here. 10.178 divided by 3.635. Now the best way to do these is to rewrite them in long division format. So you put the 3.635, or the divisor, to the left, do your division symbol, then 10.178. Now on these, you also can multiply by factors of 10 to get rid of the decimal places, and that's the best way to do these problems, just because, again, it's easier to work without the decimal places in there. And so we'd move 1, 2, 3, or multiply by 1,000 basically, and we do the same on the inside. 1, 2, 3. So now we've gotten rid of the decimal place, and remember, it's the divisor that you want to get rid of the decimal place for. It doesn't really matter on the dividend. In this case, we did get rid of all the decimal places, but that's not the most important thing. So now we look and we have 3,635, and we think, well, how many times does that go into 10,178? This is a good time to estimate a problem. And so let's just look at 3.635, or think of 3.5. And 3.5 times 2 would be 7. 3.5 times 3 would be 11.5. So 3.635, there's no way it would go into 10.178 3 times, but it should go into it 2 times. And so we put a 2 right there. So then we can do that multiplication of 3.635 times 2, and you get 7.27. Since we're not working with the decimal, it's really 3635 times 2, right? And so that is equal to 7270. So we do the subtraction there. 8 minus 0 is 8. 0. 1 minus 2, we can't do that, so we need to borrow. So we have a 10 there, and we need to change that to a 9, bring over a 1, and so now we have 11 minus 2 is 9. 9 minus 7 is 2. 2908. So now we include the decimal place, and so it's going to be 2 point. We can add a 0 on the end there and bring that 0 down. 29,080. And so we say, well, 3,635 goes into 29,080 how many times? Now here's where I think it's okay to use a calculator, because you have to kind of guess at what's going to work here. And the best way to do that is just to use a calculator and work through a few numbers. And you just think, well, 3,635 times what is going to equal around 29,000? It's going to be pretty close to 10. So let's try 9. 3,635 times 9 is 32,715, so that doesn't work. So let's go 3,635 times 8, and that actually equals 29,080. It's exactly that. So we'll put an 8 to the right of the decimal place in our quotient, and then 29080 here. Do that subtraction, we get 0. And so our answer is 2.8. And since it's a division problem, we can say our quotient is 2.8. If you're using the Saxon textbook, there's more practice problems, different ones, at the beginning of this lesson if you need some more practice on those. I know this is a long lesson, but we still got a couple of more very important parts to it. And if you need to take a break, you might want to do that now and come on back and finish this lesson up. Now, parts I and J of Lesson 4, they kind of go together on unit multipliers and conversions of length. The unit multipliers, those are also called conversion factors. And they're called unit multipliers because they have a value of unity, or 1. They're always equal to 1. And they're also called conversion factors because a factor, remember we just learned, that's something that you multiply something else by. And you're converting from one unit to another. So the unit part in unit multipliers, that should help you think of this has a value of 1, and it's also dealing with units, so it kind of has a double meaning there, like units of length or time or just whatever. So as an example, let's use something simple. Everybody knows that there's 12 inches in a foot, and so we could say 12 inches equals 1 foot. Now what does that have to do with equaling 1? Well, if you write that as a fraction, just like if you wrote 2 over 2 as a fraction, you know that that equals 1 because the numerator and the denominator are equal. Well, in the same way, 12 inches is equal to 1 foot. Those two values are equal to each other. So 12 inches over 1 foot, that's equal to 1. It has a value of unity, or 1. Now it doesn't look like 2 over 2. It doesn't look like the numerator and denominator are the same, but you know that they are the same. You know that 12 inches equals 1 foot. So you don't really worry about the numbers being the same. You just know by experience that 12 inches equals 1 foot. So if you wrote that as a fraction, it would equal 1. And therefore, if you multiplied another value by that fraction, you wouldn't change the value. You just may change the way it looks. And what we're trying to do is change the units. So if you wanted to convert 6 feet to inches, you would write 6 feet, and then you would multiply it by the unit multiplier, 12 inches over 1 foot. And so all of this is multiplication, so that means that the units of feet would cancel because you have feet in the numerator, feet in the denominator. And of course we could always write 6 feet over 1 to make it look like a fraction. When you do conversions, you want to do the multiplication. You kind of work with the number part separate from the unit part. So look at the two numbers in the numerator. 6 times 12 is 72. Over 1 times 1, those are the numbers in the denominator, so that just equal 1. So we can just write our answer 72. And then look at the units that we have left. The feet canceled, and so we've got inches there. That's the unit that we wanted. We were converting feet to inches, and so that's the unit that we put in our answer. 72 inches is the answer. Now, just like in geometry problems like we were doing with perimeter, it's real important that you write your units down. It's the same thing in these unit multiplier problems, because that's the whole purpose of it, is to change the units. And then the number changes because the units change. And so the number part is just as important as the unit part. So don't just write 72 for the answer, like in this problem, write 72 inches. I think in a problem like on a test or in your homework, each of those parts should be given equal credit. So if you wrote your answer 72, if it was on a test, you should only get half credit for that answer. If you did 50 inches for your answer, you had the units right, but you had the number part wrong, you should still get half credit because you got the units right. So I think that both of those parts are equally important. Now if you're using the Saxon textbook, on page 21 there's a table of equivalent measures there. Those would be very good to memorize, and a lot of them you probably already know, like you probably know there's 3 feet in a yard, and hopefully you know there's 100 centimeters in a meter already, things like that. If you don't know any of those, get them memorized. Let's go ahead and do a practice problem. Convert 60 feet to centimeters. Now the first thing you do anytime you do a unit multiplier problem is you write down what's given first. You've got 60 feet, that's what's been given, that's the value that you've been given, 60 feet. And you can always write that as a fraction if that helps you think about it. 60 feet over 1. So write that down first, then think about, I've got to convert that to centimeters, so how would I get there? Think about how you would get there first. Well, you could convert feet to inches, because you know that there's 12 inches in a foot, and then you could convert from inches to centimeters. So you're going to need 2 unit multipliers to complete this problem. So first you wrote down what was given, then you thought about what unit multipliers you would need. So next I would just go ahead and put a pair of parentheses here to represent where you're going to put your unit multipliers. Then go ahead and write them in. 12 inches over 1 foot, and then the other one is 1 inch is equal to 2.54 centimeters. And notice I put my units down on everything because the units are just as important as the number here. Now the next thing you do is cancel your units because you want to end up with centimeters, and so you say feet over feet. You have feet in the numerator and in the denominator, so those cancel. And now look at your inches. You have inches, but wait, we've got inches times inches here. It's got to be inches divided by inches. We have to have centimeters for our answer. So this problem is not correct. We have to flip that second conversion factor to put 2.54 centimeters over 1 inch. So let's go ahead and do that. Now I did that on purpose to show you how important it is to have the units and the unit multipliers in the right place. Occasionally I do make mistakes, but that time I did that for a reason, so that you could see the inches over inches, those cancel now, and you're left with centimeters. You always want the unit you're trying to get to be the last one there in the numerator. Okay, so now all we have to do is do our multiplication, and the way they want the answer in the Saxon textbook is just the factors. So 60 times 12 times 2.54. Those are our factors that we have. The 1 times 1 times 1, we really don't worry about those. It's just understood that those are there, and then our units. So we just write the answer like that. We don't have to multiply it out and figure out the answer. The reason for that is that's not the goal of the problem. The goal is for you to convert and to know how and the steps involved in converting from one unit of length to another. By now you should be able to do multiplication pretty easy. I mean, you could just type that in your calculator. But if you can't do those steps like that to get that answer, then that's a problem. Let's do one more problem. Convert 740 centimeters to kilometers. So first, always what you do on a unit multiplier problem is to write down what's given, 740 centimeters. Then you think about what you need to do to get from centimeters to kilometers. Well, let's just think about it. We know that there's 100 centimeters in a meter, and there's 1,000 meters in a kilometer. So we'll need 2 unit multipliers, just like in the previous problem. So let's just go ahead and put 2 sets of parentheses down. And the first one, we need to go from centimeters to meters. And we know that in 1 meter there are 100 centimeters. And you need to make sure and write it so that the units cancel. We could go ahead and do that right now That's a good idea to just go ahead and do that, so you know that you've got those centimeters canceled. Now you can go from meters to kilometers. And so you would say 1 kilometer. Remember, the unit that you're trying to get to should always be there on the top, and it is, over 1,000 meters. And so those meters cancel. And so we've got 740. Now we have two values on the bottom or in the denominator, so just multiply those together. 100 times 1,000. Remember, we just write all the factors out in these unit multiplier problems, and then we put our units at the end. We don't actually do the multiplication and division to get an actual numerical answer. Writing the answer like this, 740 over 100 times 1,000, shows that you know the steps that were involved in converting that particular value. Make sure you understand unit multiplier problems. These are really important, especially if you're thinking of going into a science or engineering type of field, because you're constantly having to convert from one type of unit to another, and so you need to just be able to do that very efficiently. Write down the value that's been given first, then think about what conversion factors you need to get to your answer, or to get to the desired units. Then put those unit multiplier in as factors in the problem. Cancel your units, make sure that they cancel, and make sure that the unit you're trying to get to ends up at the top or in the numerator of the last conversion factor. Okay, well, that's finally all for lesson 4.